Good day, kids. We are now in the second week of quarter two. So be ready with your modules, pen and paper as we go into the awesome world of mathematics. My name is Mr. Alan De Lejero. I am a grade 4 math teacher in Balangasan Central Elementary School. Today, we will be discussing writing prime factors of a given number, finding the greatest common factor or GCF, and finding the common multiples and the least common multiple or LCM. Our objectives: at the end of the video lesson, you are expected to write prime factors of a given number, find the greatest common factor, and find the common multiples and the least common multiple. Children, let's sing this rap song.
I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 2, 3, 5, 7, 11. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 13, 17, 19, 23, 29. Yeah. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 31, 37, 41, 43, 47. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 53, 59, 61, 67, 71. Hey. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 73, 79, 83, 89, 97. Yeah, representing prime 1 to 100. Let's go. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Yeah, yeah, prime numbers. Prime numbers.
Children, get ready with your pen and paper because it's drill time. Give the answer to each question. Question number 1. What is the only even prime number? You have 10 seconds. Your time starts now. Your time is over. If your answer is 2, very good. Number 2, find all the prime numbers between 30 and 40. Your time starts now. Let's check your answer. The answer is 31 and 37. Number 3. What prime number must be multiplied to 12 to get 132? Your time starts now. If your answer is 11, great. Number 4, find 4 prime numbers whose sum is 25. Your time starts now. If your answer is 2, 5, 7, 11, very good. Number 5, find a pair of prime numbers whose difference is 6. Go. Your time is over. If your answer is 17 and 23, you are right. Because 23 minus 17 is 6. And if your answer is 37 and 43, very good. Children, I'm so glad that you were able to understand our previous lesson. Now, how many prime numbers in 1 to 100? If your answer is 25, you are correct. And prime numbers have exactly 2 factors, 1 and the number itself. And these are the prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. And these prime numbers are from 1 to 100. Let's proceed to activity 1 under what's in. Activity 1, writing prime factors. But before that, we will review first the 2 key ideas in writing prime factors. Number 1, we have factors. From the word here, prime factors. So factors are numbers that you multiply together to get the number as a product. Example, 5 times 10 equals 50. And 5 and 10 are the factors of 50. And number 2, prime number. A prime number has exactly two factors, 1 and itself. Let's continue activity 1, writing prime factors. We have here number 75. What prime numbers can we multiply to get 75? Let us identify this using a factor tree. So we have here 75. So think of factors when we multiply, the result is 75, and we have here 5 and 15. 5 times 15 equals 75, and 5 is a prime. Means we have to stop here. We have to bring down 5. And 15 can still be factored because 15 is a composite number. First, you have to think of two numbers. When you multiply it, the result is 15. And we have here 5 and 3. 5 times 3 is 15. Now 5 and 3 are prime numbers. So 75 equals 5 times 5 times 3. So we can say that 5 and 3 are the prime factors of 75. Therefore, 75 is the product of its prime factors of 3 times 5 times 5. Now you have noticed here, we write the factors from greatest to least. And this one from least to greatest. So what we did is what we call prime factorization. Using a factor tree, we try to identify all possible prime factors of a given number. This means that the factoring process goes on until all the remaining factors are prime. Let's do another example. What are the prime factors of 42? Now we have here the number 42. Think of factors when you multiply it, the result is 42. And here we have 6 and 7. 6 times 7 is 42. 6 can still be factored. Why? Because 6 is a composite number, while 7 is a prime number. So you have to stop it here and bring down 7. So 6 is a composite number. So we have here 2 and 3, because when we multiply 2 and 3 equals 6. So 2 and 3 are already prime numbers. So 42 equals 2 times 3 times 7. We say that 2, 3, and 7 are the prime factors of 42. Therefore, 42 is the product of its prime factors 2 times 3 times 7. Let's proceed to exercise A under what's new. Write the prime factors for the following numbers. You have 5 minutes to answer this, and your time starts now. Your time is over. Let's check your answers. Number 1 is 30. And we have here, and we are using factor 3. On the left side, in color black, is a prime number. Here on the right side is a composite. Okay? First, you have to think of factors when you multiply it. The result is 30. And we have here 5 and 6. 5 times 6 equals 30. And 5 is a prime number. Bring down 5, while 6 is a composite number. So we have to factor this number. And 2 times 3 is 6. 2 and 3 are prime numbers. So we have to stop factoring this number. And we have here 30 is equal to 2 times 3 times 5. The prime factors of 30 are 2, 3, and 5. Let's proceed to number 2. Number 2 is 6. 2 times 3 is 6. 2 and 3 are prime numbers, so we have to stop. So 6 is equal to 2 times 3. And 2 and 3 are the prime factors of 6. Number 3, 21. 21, we have here 3 and 7. Factors 3 and 7 are prime numbers. So it means 21 is equal to 3 times 7. So these are the prime factors of 21, 3 and 7. Then we have number 4. Number 4 is 60. Again, we have here factors 6 and 10. 6 is a composite number, so we can still factor this number. So the factors of 6 is 2 and 3. 2 and 3 are prime numbers. 10 is a composite number, so we have to factor this number 10. And 2 and 5 are factors of 10. So we have here the factors or the prime factors of 60. 60 equals 2 times 2 times 3 times 5. We can also write 2 times 2 in exponential form. The prime factors of 60 are 2 squared, 3, and 5. Number 5 is 63. Think of factors when you multiply it, the result is 63, and we have here 7 and 9. Since 7 is a prime number, so we have to bring down 7. And 9 is a composite number, so we have to split it to 3 times 3. 3 times 3 is 9. 3 and 3. This number 3 is a prime number, so we have to stop. 63 equals 3 times 3 times 7. And we have here 3 times 3. So we can also write this one in exponential form. So the prime factors of 63 are 3 squared and 7. Number 6 is 15. So we only have here 5 and 3. 5 and 3 are prime numbers. So the prime factors of 15 are 3 and 5. Let's proceed to exercise B. Copy the exercise below on your paper, but no need to copy this in your paper. All you have to do is to color the wings of the butterflies with the prime factors of a given number on its body. So we have here 3 butterflies. The first one is 87, then 98, and 63. Any color, do it here in your modules. And you have 2 minutes to answer this. Your time starts now. Okay, your time is over. And butterfly A has an answer already. We have here 87. The prime factors of 87 are 3 and 29. The next butterfly, okay, 98. So we have here the prime factors of 98. 2, 7, and 7. And for butterfly C, 63, we have 3, 3, and 7. Okay. Let's proceed to activity 2. Find the GCF. GCF, or the greatest common factor. The common factors are, when we say GCF, the common factors are those factors that are all common in the two or more numbers. The largest factor among those common factors will be the greatest common factor, or the GCF. And we have here the word problem. Let's read together. Arvin's father has 2 pieces of wood that will be used for the house renovation. One is 15 meters long and the other is 21 meters long. He plans to cut both into smaller pieces of equal length without wasting any part of the wood. How long should each of these smaller pieces be? So we have here 15 meters and the second wood, which is 21 meters. So we can help Arvin's father by looking for the GCF. Now to find the GCF, we can list all the factors of 15 and 21 first. So we have here the factors of 15. 1 times 15 equals 15. And 3 times 5 equals 15. And we have 4 factors of 15. We have 1, 3, 5, and 15. And the factors of 21 are, we have here 1 times 21 equals 21, and 3 times 7 equals 21. And these are the factors of 21. 1, 3, 7, and 21. And the common factors are 1 and 3. As you have observed, 3 is encircled. So the greatest common factor, or the GCF, of 15 and 21 is 3. When we compare 1 and 3, of course, 3 is bigger than 1. So meaning 3 is the GCF. So Arvin's father will cut both pieces of wood into shorter pieces that are 3 meters long each, so that no part of the wood is wasted. Now the method we just used is called the listing method. Let's find out the 2 other ways to find GCF of a number. But before that, let's answer first exercise A under what's new. Find the GCF of the following pairs of numbers using listing method. You don't need to write your answers in your paper, but you need to write your answers in your modules. Are you ready, children? And you have 5 minutes. Okay, your time is over. Let's check your answers. Now we have here number 1, 10, and 15. The factors of 10, we have here 2 times 5 is 10. 1 times 10 is 10. And we have here 1, 2, 5, and 10. So these are the factors of 10. And for the factors of 15, we have 1 times 15, 3 times 5. 1, 3, 5, and 15. Okay, these are the common factors of 10 and 15. We have here 1, 1, and 5. 2 here is not included. Sorry. So the GCF, so we have here the common factors of both 10 and 15 are 1 and 5 only. 1 and 5. So the largest among these factors is 5. So meaning the GCF is 5. Number 2, 12 and 16. So these are the factors of 12. 1 times 12, 2 times 7, and 3 times 4. So list all the factors of 12. We have here 1, 2, 3, 4, 6, and 12. And for 16, we have 1 times 16, 2 times 8, and 4 times 4. 4 times 4 is also 16. So list all the factors of 16 from least to greatest. 1, 2, 4, 8, and 16. And we have here 1 or the common factors of both 12 and 16 are 1, 2, and 4. The largest among these factors is 4. Therefore, the GCF is 4. Number 3, 20 and 24. So 1 times 20, 2 times 10 equals 20, and 4 times 5 equals 20. So these are the factors of 20. 1, 2, 4, 5, 10, and 20. And for the factors of 24, we have here 1 times 24, 2 times 12, 3 times 8 is 24, and 4 times 6 is 24. Okay, 24 equals 1, 2, 3, 4, 6, 8, 12, and 24. So the common factors of both 20 and 24 are 1, 2, and 4. So the largest among these factors is 4. Therefore, the GCF is 4. Exercise B. Choose the greatest common factor of the given pairs of numbers from the parentheses. You have 2 minutes. Your time starts now. Okay, your time is over. Let's check your answers. Okay, we have here number 1, 6 and 9, and the GCF is 3. Number 2, oh no, we have to discuss first, or we have to list all the factors of 6. We have here 1 times 6, 2 times 3. So the factors, and these are the factors of 6. 1, 2, 3, and 6. And for 9, we have 1 times 9 and 3 times 3. Okay, factors 1, 3, and 9. And we have here the common factors 1 and 3. And the largest is 3, so it means 3 is the GCF. Number 2, 12 and 16. If your answer is 4, you are correct. And these are the factors of 12. 1 times 12, 2 times 6, 3 times 4. So 2 or 1, 2, 3, 4, 6, 12 are the factors of 12. And for 16, we have 1 times 16 is 16. 2 times 8 is 16. And 4 times 4 is 16. And the factors are 1, 2, 4, 8, and 16. And the common factors, we have here 1, 2, and 4. So the GCF, among these factors, the largest is 4. So the GCF is 4. Number 3, 20 and 30. And if your answer is 10, you are correct. So the GCF is 10. So these are the factors of 20. Here, 1 times 20, 2 times 10, 4 times 5. So 1, 2, 4, 5, 10, 20. We have 30, 1 times 30, 2 times 15, and 3 times 10. 5 times 6 is also 30. So these are the factors 1, 2, 3, 5, 6, 10, 15, and 30. So the common factors, we have here 1, 2, 5, and 10. So the GCF is 10. 10 is the largest common factor or the greatest common factor. Okay. Number 4, if your answer is 8, very good. So we have here the factors of 24. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. So 1, 2, 3, 4, 6, 8, 12, and 24. So we have here from least to greatest. 1, 2, 3, 4, 6, 8, 12, and 24. And for 32, we have 1 times 32, 2 times 16, 4 times 8. Okay, the common factors are 1, 2, 4, and 8. So the GCF, the greatest common factor is 8. Okay. Let's proceed to activity 3. Find the least common multiple. When we say LCM, or the least common multiple, the common multiples are those multiples that are common or the same in the given numbers. The smallest multiples among those common multiples will be the least common multiple, or LCM. Let's read the problem. Karina baked puto. She wants to pack them in boxes of 8 and 12 pieces. What is the smallest number of pieces of puto that she can pack using the boxes? So to solve the problem, you need to find the least common multiple, or LCM, of 8 and 12. Here's how you do it. First, by listing method. So write the multiples of 8. We have here 8, 16, 24, 32, 40, and 48. As you have noticed here, you will notice that 8 is added to 8 becomes 16, and 16 plus 8, 24. Then 24 plus 8 is 32. Then 32 plus 8 is 40. And 40 plus 8 is 48. Or simply skip counting. So you have to skip count here. 8, 16, 24, 32, 40, and 48. Then write the multiples of 12. Skip count 12, 24, 36, 48, 60, and so on. We have here 12 plus 12, 24. 24 plus 12 is 32. 32 plus, 36 plus 12 is 48. And 48 plus 12 is 60. So the common multiples we have here 24 and 48. So the smallest multiple among these common multiples is 24. So the LCM is 24. Another example, find the least common multiple of 8 and 12 by prime factorization. So we have here factor 3, 8. 8, think of factors. When you multiply it, the result is 8. So we have here 2 times 4 is 8. Now, 2 is a prime number. So 2, bring down 2. Then 4 is a composite. Let's find factors of 4. When we multiply it, the result is 4. So we have here 2 times 2 is 4. And 2 times 2 times 2 is 8. So 2 times 2 is 4. 4 times 2 is 8. So these are the prime factors of 8. 8 equals 2 times 2 times 2. And for 12, we have here 2 times 6 equals 12. 2 is a prime, bring down 2. 6 is a composite number, so we have to split 6. 2 times 3 is 6. And 2 and 3 are prime numbers. So we have to stop here. Then 12 is equal to 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. Now, here are the rules. Number 1, use one factor from every column. Number 2, use only one factor from a vertical pair. So we have here pair. So we use only one number, which is 2, and another pair and 2, and we have here 2, bring down 2, and bring down 3. After that, multiply all the prime factors. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So the LCM is 24. Another method is by continuous division. So we have here 8 and 12. We inverse the division symbol. Here, we have here 8 and 12. So think of a prime number that can be divided both 8 and 12 without any remainder. So we have here, since 8 and 12, here, divide it by 2. So we try 2. So divide. 8 divided by 2 is 4. And 12 divided by 2 is 6. So 4 and 6 are composite numbers. So think of a prime number that can be divided without any remainder. So we have here 2. So 4 divided by 2 is 2. And 6 divided by 2 is 3. So another one, we have here 3. So 3 divided by 2 divided by 3 cannot be, so bring down 2. 3 divided by 3 is 1. So we have here 1. We have here 2. So 2. 2 divided by 2 is 1. So on this side, you have to write it here. So LCM equals 2 times 2 times 3 times 2. So 2 times 2 is 4. 4 times 3 is 12. And 12 times 2 is 24. So notice that 24 is the least common multiple or LCM of 8 and 12. Therefore, the smallest number of pieces of puto that can be packed using the boxes is 24. You do not include 0 when dealing with common multiples. Okay, let's answer exercise A. Find the common multiples and the least common multiple or LCM of each pair of numbers. Some of the multiples are already given. Okay? And this is, or you have 2 minutes. Your time starts now. Time is up. Let's check your answers. Okay, for number 1, we have here the common multiples. We have 4, 8, 12, 16, and 20. And the least common multiple is 4. So the LCM is 4. And for number 2, we have here the common multiples 24 and 48. And the LCM is 24. If your answer is correct, great job. Let's proceed to exercise B. Circle the letter of the correct answer in 2 minutes. Your time starts now. Time is up. Let's check your answers. Okay, for number 1, a common multiple of 6 and 4 is, the correct answer is letter A, 12. So listing method, 6, we have here skip count, 6, 12, 18, 24, 30, and so on. 4, skip count, 4, 8, 12, 16, 20, 24, 28, and so on. The common multiples are 12 and 24. So the LCM is 12, or the smallest common multiple is 12. If your answer is letter A, very good. Now for number 2, if your answer is letter D, very good. And we are now using the factor tree. We have here 4 and 20. Common multiple of 4 and 20. For 4, we have here 2 times 2 equals 4. So the prime factors of 4 are 2 times 2. And these are the prime factors of 20. We have here 2 times 2 times 5. For 20, we have here 2 times 10 is 20. 2 is a prime number, bring down. 10 is a composite, so you have to split. 2 times 5 is 10. 2 and 5 are prime numbers. So we have to stop. So we have here the common multiples. We have here 2. So right here 2, another pair 2, then the last one is 5. So multiply 2 times 2 is 4. 4 times 5 is 20. So the LCM is 20. Okay, for number 3, we have here the LCM of 15 and 9 is, if your answer is letter B, very good. You are correct. So we have here continuous division. So 15 and 9, think of a prime number that can be divided by, or a quotient by 15 and 9. So we have here 15 divided by 3 is, the quotient is 5, and 9 divided by 3 is 3. So you stop. List all the prime factors. 3 times 3 times 5. So 3 times 3 is 9. 9 times 5 is 45. So the LCM is 45. Remember, prime factorization is the process of expressing a number as a product of its prime numbers. The greatest common factor, or GCF, of two or more numbers is the largest number that is a factor of each. And the least common multiple, or the LCM, of two or more numbers is the smallest number which can be divided by each of the given numbers. The LCM contains all the prime factors of each of the given numbers. Okay, for your assessment, we have here exercise A. Write the prime factors using the factor tree. Start with the 2 boxes, then continue as needed. And we have here example. Number 20, prime factors of 20. So we have here 2 times 10, 20. 2 is a prime, bring down 2, and 10 is a composite. So 2 times 5 is 10. So these are the prime factors of 20. So start number 1. The number 1 is 96. And number 2 is 78. And for letter B, write true if the statement is correct and false if it is incorrect. So you have to, we have here 5 numbers. And letter C, complete the table below, find the LCM, write your solutions inside the box, or write your answers in your module. We have here the methods. We have the listing method, prime factorization, factor tree, or continuous division. We have here LCM of 8 and 12, LCM of 56 and 40, LCM of 30 and 45. And here are the examples. We have here the listing method, the prime factorization method or factor tree, and the continuous division. See you next time, kids. Thank you for watching.